Alright, so good everybody. I welcome you back to Ajaks Tutorials YouTube channel. My name is Ajaks, CEO founder Ajaks Tutorials, and in today's video, we are going to be looking at physics, scalars and vectors. Yes, we are going to dismantle every aspect of scalars and vectors in today's video. So please, I want you to stay tuned, get your earphone, get your earpiece, cut off any form of distraction. Let's get into this video. Now, in this video, we are going to be looking at scalars and vectors introduction. I'm going to be defining what a scalar means and what a vector means. All right. I'm going to look at vector resolution. 5 cases of vector resolution: the parallel, the perpendicular, when it is acute, when it is opposite, when it is obtuse, and when there are more than 2 forces acting at a point. We're going to dismantle all of these in today's video. Then we are going to solve 28 JAMB and WAEC questions. 28. Yes, you heard me right. 28. So please make sure you're with your book and pen. This is not a video that you just balance on your chair and watching. No, be with your book and pen because it is going to be what? Engaging. All right, let's get into this video. Firstly, what's Ajaks Tutorials all about? 2026 JAMBITES come close. In 2025, Ajaks Tutorials produced 239 students with 300 plus, and we had our top student emerging top 8 in Nigeria, 372 over 400, as Onyeme Samuel. Now, over the years, I've understood that many students that fail JAMB, they don't fail JAMB because they don't read. Alright, many of them, they don't have the right guidance. Ajaks Tutorials 2026 JAMB classes is going to be starting January 5th and runs down till your examination. The fee for this class is 8,000 naira monthly. We have other plans for you. In case your parent or guardian want to pay for more than a month, we have the plan for you. To be a part, click the link below now, text number on your screen. Remember, in 2025, we have 239 students 300 plus. 2026 will not be any different. Class is for science students only, and class holds online. We use WhatsApp, Telegram, YouTube, and our mock portal for our classes. Click the link below now or text number on your screen to make inquiries and enroll. Have a lovely day. Bye. Alright, so welcome back. Let's start proper. Now, what is a scalar? What is a vector? Listen attentively. A scalar quantity is a quantity that has magnitude and no direction. Alright? Magnitude meaning value. Okay? So when I say the length of a meter rule is the length of this particular thing, when I use the meter rule to measure it, is, let's say, 30 centimeters. Now, that 30 centimeters is a magnitude. Do you understand? If I say the weight of my body is 30 newtons, that 30 newton is a magnitude. But now listen, let me tell you the difference. For scalar, there is no direction. For vector, it's a quantity that has magnitude and direction. That is, when I'm talking about 30 meters, I'm not giving any direction because meters, length, distance is a what? Scalar. Now, when I'm now talking about the weight, 30 newton. So, where is it acting? Is it down? Is it up? These are what we call directions. So, any quantity that has just magnitude is a scalar. Any quantity with magnitude and direction is a what class? Vector. I hope that makes a lot of sense. Now, we are done with the introduction. Now, let's get into vector resolution. We are going to be looking at 5 cases today, and please, I want you to put pen on paper. Please, you have to write. Now, case 1 for vector resolution. Case 1. And this case is going to be when we are having 2 vectors. So when I mean a vector, I don't want us to limit our mind to force alone. Force is a vector, yes. But in this video, we are going to be making use of force very, very well. That doesn't mean force is the only kind of vectors. Velocity is the vector quantity. Displacement is the vector quantity. I hope that makes sense, all right? But in this video, we're going to be looking at what? Force. Now, the case 1 is when 2 forces are what? Parallel to each other. To each other. Blah, blah, blah. Okay? Now, what do I mean by parallel? Please pay attention. Let's say you have a force F1, all right, and you have another force F2. So they are parallel, but moving in the same direction. Yes, let me add this, is in the same direction. All right, so they are parallel but moving in the same direction. This is my case 1. This is what we call resultant. A resultant force is that one force, all right, that has the same effect in magnitude and direction when these two forces are being combined. That's what a resultant force is. So you're going to be asked to find resultant, find the resultant this, find the resultant that. So that's what resultants mean. Now, in all the cases, I'm going to be teaching you how to find the resultant. That's why it's called what? Vector resolution. We are resolving these vectors to get what? The resultant. Okay? So, F1 plus F2 is how you can resolve a force when it is parallel to each other in the same direction. So, the resultant force, F resultant, is equal to what? F1 plus F2. Now, like I said before, a vector quantity has magnitude and direction. It means that if I am defining the resultant by just adding these two forces, what I have gotten is what we call the magnitude. So this is the magnitude. Now, class, how can we determine the direction of this resultant force? Class, in my videos on bearing and distances, please check it out after this video, bearing and distances, I dismantled the key things, the foundations for scalars and vectors. So just go and check out the video when you're done. Now, let me draw this here. The cardinal points. We're going to be needing it very, very well. So this is north, this is east, this is west, and this is south. Now, how can I determine the direction of my resultant force? Class, the direction of this resultant force is basically where these things are moving. So these things, they are moving towards the what? East. So it means that had it been, let's say for example, this force here was 2 Newton and 3 Newton moving parallel to each other in the same direction, then my resultants will be what? Fr equal to 2 plus 3, which is 5 Newton, east. This is my what? Resultant. So it is only going to be a blunder if you are stating a vector quantity without its direction, except the question states otherwise. I hope that makes a lot of sense. So please never forget that, okay? This is how to find when two forces are parallel to each other in the same direction. Now, case 2. Case 2. Case 2 is when two forces parallel, okay, two forces in opposite direction. Two forces in opposite direction. Two forces in opposite direction. Now, when two forces are in opposite direction, how can you resolve this force? Now, please pay attention. Let me rub off this cardinal point stuff. I hope we have jotted this down because it's extremely important to So, two forces in opposite direction. So let's use this F1 is going like this, all right, and this F2 is going like this. Now, class, please pay attention. I want to do something very interesting. When these two forces are in opposite direction, and we have to find, let me draw it like this. And we have to find the resultant of this force. We have to find the resultant of this force. Fr in this case is going to be, now, it's going to be the subtraction of each of them. Now, let me explain something to you. You are going to subtract the one with smaller magnitude from the one with larger magnitude. So, using still this same example, let's imagine that force 2 Newton and force 3 Newton, they are in opposite direction on a straight line. How can you find the resultant force, class? It's going to be what? F2 minus F1. And this gives me what? Fr equal to what? 3 minus what? 2. That's what? 1 Newton. Now, we have gotten our 1 Newton as the magnitude. What is going to be the direction? Class, please note this thing now, that when two forces are in opposite direction, so this is actually called, you can either say they are in opposite direction parallel to that, or you can say they are anti-parallel. Anti-parallel. Alright, don't forget that. Anti-parallel, okay? So, the direction is going to be where the bigger force is. So, if you have 10 Newton and 15 Newton going like this and like this. So 15 is here, 10 is here. The direction of your resultant, when you have gotten the resultant, 15 and 10, the resultant is 5 now. 15 minus 10. I told you where is the opposite direction, you subtract. If they are moving in the same direction, you add. So 15 minus 10 is 5. But where is the direction going to be? Yeah. So this is what? To the left. Alright? So this particular question now, where is the bigger magnitude? This one. So the direction of the resultant will be what? To the what? Left. Or you can say to the west is better. So either they might put left or right. You know how it is now. North is up, south is down, east is like this, right? West is like this, left. So let's just be using north, east, west, south. Okay? So this is 1 Newton west. I hope this makes a lot of sense. So that's basically case 1, case 2. Very simple. So let's say, for example, now you are having 3 and, or you're having 7 and 3. That's going to be what? 7 minus 3, which is 4. 4 east. 4 Newton east, because it's towards the right. I hope that's correct. Good. Now, case 3. This case 3 is a very, very important case because your JAMB examination asks questions on it a lot. Case 3 is when two forces are perpendicular. So you can either say perpendicular or at right angle to each other. Alright, so perpendicular at what? Right angle to each other. Now, how can you do this? Now, please pay attention. So, let's say you have force F1 and force F2. And you have to find the resultant. Please, class, note that the resultant of two forces is usually drawn. So this is perpendicular, so like this, right? So when it is perpendicular, F arrow, I'll show you where F arrow be, but just please pay attention that the resultant must be drawn from the point of intersection of these two forces. Are you getting it? So this is the point of intersection here. So you draw the resultant from here. And this is my what? F arrow resultant. And goes like this. Right? Now, please pay attention. I want to do something very interesting. Pay attention. This is my resultant. Right? So, class, we will agree with me that this is F1, right? We will also agree with me that if I put this thing here, I can still say this place is F1. Are you getting me? And we will agree with me that this one now, if it comes like this, I can still say this place is what? F2. Now, class, what is this trying to show you? Let me tell you what it's trying to show you. It's trying to show you a triangle like this. So this triangle now, don't forget that since this place is F1 and here is F1, this is parallel to this place. So here is also 90. Now, what's the resultant going to be? So it means that this place is F1. Remember, this is still F2, right? So what's the resultant going to be? Class, this is already looking like using Pythagorean theorem. Okay, so Pythagorean theorem, when we want to use it, what do we say? Hypotenuse squared. Class, what's the hypotenuse in this case? The resultant. So resultant squared is equal to opposite squared, this place. So if we are saying this is opposite squared, it means that this is an angle theta. So f1 squared plus adjacent squared, f2 squared. Class, this is the formula for finding the resultant in a what class? Perpendicular, where two forces are perpendicular to each other. Now, we have gotten the resultant. What is the direction? The direction is this theta. And the direction can also be still this theta. So let's say this is theta 1, this is theta 2. Yes, true. Don't tell me Ajaks is a lie. It's true. Because some questions will tell you what's the resultant and find the direction. That direction you are finding the direction of the resultant to this force alone. You must understand that regardless of where the theta is, direction is direction. It now depends on your question that will not put you in the right track on what to use. Now let me explain what I just said. Please pay attention. The direction of this resultant FR can either be theta 1, but you are going to put your English as saying that this theta 1 is towards the F2, or this theta 2 is towards the F1. Do you understand? Now, so don't just normalize your understanding on this one to just be the only theta. No. Some questions can go as far as telling you what is the angle between the resultant and what? F1. How can you do that? The angle between resultant and F1 is theta 2. The angle between the resultant and F2 is theta 1. And don't forget that the moment you can get theta 1, you can get theta 2. By saying what? 90 minus theta 2. Do you get? Good. So, I have explained that. Now, let's clean the theta 2 so that we don't get confused. How that's clear. So, I've established that the direction can come in different ways dependent on what the question is asking you to do. Okay? So, let's solve now. How can we get my theta? From soak à toi. So, soak à toi, tan is what? Tan theta is opposite over adjacent. So, this is my opposite, F1. And my adjacent, F2. Class. My theta, which is my direction, is equivalent to tan inverse of F1 over F2. This is my what? Direction. And don't forget that this theta is the direction of the resultant to F2. Whereas, if the question asks you the theta to the direction to F1, you just subtract this whole thing from 90. Or you flip these two things. You can try it. It will work. But don't worry. Don't stress yourself. Just when you get your answer, do 90 minus theta. So it means that theta 1 is equal to 90 minus theta 2. Do you understand? Theta 2 here. So to get theta 2, it means 90 minus theta 1. I hope this is clear. So I hope I've been able to explain this thing in depth and we understand case 3, because we're going to solve a lot of questions on this case most especially. Okay, so please make sure you understand what I'm trying to say. The resultant is basically F1 squared plus F2 squared. Take the square root. If you ask to find direction, sometimes JAMB might be chill, WAEC might not be. So it depends, alright? But this is the direction. Now let's move to case 4. Let's go case 4. 4. So this is how it's going to go. I'm going to do, okay, that was 1. It's actually 6 cases. So it's 6 cases, not 5. It's 6 cases. So case 4, when I do case 4, I'll do case 5. Then we'll solve question on case 1 to 5. Then we'll not do case 6, then solve a question there. Alright, because case 6 is very large. So now case 4 is when two forces or two vectors. So two vectors or forces, they are at acute. So when two forces are at acute angle to each other. Class, what do I mean by acute angle? Now please note this thing down. An acute angle is an angle that is less than 90 but greater than what? 0. So this is what it means. Do you understand? So when you have a force here, F1, and you have a force here, F2, and they're at an angle, acute angle theta to each other. So this is an acute angle. Example 45, 30, 65, 75. But the moment I start entering 115, no, it's no longer acute. I'll tell you what it means later. Okay? So this is an acute angle. Now, how can you find the resultant in this particular kind of case? So the resultant for an acute angle, I'll teach you what it is. Now, please, let's look at our screen. This is what we call parallelogram law of vectors. You're going to see it on your screen now. It states that the parallelogram law of vectors addition states that if two vectors are represented by the adjacent sides of a parallelogram, their resultant vector is present by the diagonal of the line, by the diagonal drawn from the common point of two vectors. Now, the diagonal shows both magnitude and direction. Please pay attention. Let me tell you something. Please note this down. The properties of a parallelogram. Now, the first property is that a parallelogram has the opposite sides. It has its opposite sides. Its opposite sides to be parallel. So parallel to each other. Okay? Now, 2. It has its opposite angles. Opposite angles parallel to each other. Just blah blah blah, write that down. Parallel to each other. And the third one is that a parallelogram has its opposite angles parallel to each other, opposite side. So let's just work with these two. There are actually 3, but this is the most important one. There is no point bombarding your brain with so many things. Now I will explain what these two things mean. So we are still back on finding the resultant of two vectors that acute angle to each other. So this is how it's going to go. We are going to agree with me that if this place is F2, then here 2 is F2. Right? And we're also going to agree with me that if this place is F1, then here, let me put this F2 outside. We are going to agree with me that here is what? F1. So this place is F1, this place is F2. Class, what is this looking like? A parallelogram. Parallelogram, okay? So a parallelogram has its opposite sides parallel. I want to say parallel and equal. So the opposite sides of a parallelogram are parallel and equal. The opposite angles. Now, what do I mean by opposite angles? This is theta. This is an opposite angle. So a parallelogram law, this is equal to this. And this is equal to this. Now, that is not our problem. For parallelogram law of vectors, see it on your screen again. It says that when two vectors are parallel to each other, all right? Now, when two vectors in a parallelogram are drawn from the adjacent side, what happens to the resultant? It says that the resultant is drawn from the common point of intersection. So the common point, this is my resultant. This is my what, class? Resultant. This is my resultant. So listen to this. Listen to this. I want to do something now. if you have a parallelogram and you are having here to be theta, parallelogram law says that this place is also theta. Abi now, and it says that if this is theta 2, this place is also theta 2. This is what parallelogram law is telling us. So now let's imagine that this theta was 30 degrees. It means here will also be what? 30. So 30 plus 30 is what? 60. It means, and don't forget that a parallelogram is a quadrilateral. A quadrilateral is a shape that has 4 sides. So this is 1, 2, 3, 4. Any shape with 4 sides always have the sum of angle in them to be 360. Do you understand? Normal mathematics now. So this place 2, 3, 4, 360. So it means that if this was 30 and here is 30, that means I'll be having 30 plus 30 plus theta 2 plus theta 2. Everything must sum up to what? 360. Are you following? Now this is giving me what? 60 plus 2 theta 2 and it's what? 360. What is going to give me? 2 theta 2 is equal to 360 minus 60. That gives you what? 300. Divide both sides by 2. It means theta 2 is what? 150. So it means that the angle here is 150 and the angle here is 150. Now, if you notice, that 150 can also be gotten by saying 180 minus theta. So it means that instead of doing all this sharing, I can basically say this place is 180 minus theta. I hope this is clear. Now, we are getting somewhere. We have gotten 180 minus theta. And this place is F1, this place is F2. This is my resultant. Class, I will make a video on cosine anyways, but now let me just tell you. To find the resultant of a parallel, when two forces are at acute angles in a parallelogram, so the resultant here is going to be what? From cosine rule, FR squared is equal to F1 squared plus F2 squared minus 2F1 F2 cos 180 minus theta. This is the answer for the word resultant. Now this cos 180 minus theta is because there is something here. That's the 180 minus theta here. Because cosine rule is just basically telling us that when we have a triangle, alright, and two sides of the triangle are given, two sides, let's say this place L1, L2 are given, but there's nothing here, and there is an angle that is given in between this thing, then I can apply cosine rule from here. So this tells us that cosine rule tells us that this thing is r squared equal to L1 squared plus L2 squared minus 2L1 L2 cos theta. This is the theta here. Do you understand? So you use cosine rule when two sides of a triangle are given and the angle between those two sides are given. That's when you use cosine rule. So the two sides are given and the angle between them is given. So this, if you clean this thing now, you clean this thing, you are going to be getting a triangle. So this thing I just said now is similar to this thing. So that's why the formula is like this. Now, what is going to be the direction? What's the direction? Now, don't get confused. Don't get confused. The direction of this parallelogram, the direction of this resultant is not this. This is direction. Good. Alpha 1 and alpha 2. So, the direction of alpha 1 is the direction of the resultant, the direction of FR to F1 force. And alpha 2 is what? The direction of the resultant FR to F2. Do you understand? So that's the same thing I was telling you in the perpendicular part, that the direction is this resultant to the F1. This is not direction. We just use this thing to be able to find the word FR. So the direction is basically this thing here. and this thing here. So the question tell you what's the direction of the resultant force to the F1 force. This is alpha 1. If it's direction of the resultant force to the F2 force, this is what alpha 2. And how can you get this direction? Sine rule. We're going to do sine rule, don't worry. Okay, we'll do sine rule in this video. So this video is fully packed. So please, if you know what's good for you, I beg you, don't go. If you are tired, just go and rest. Come back to it, because after this video you are going to know scalars and vectors. Like say now you write, now you invent them. All right, so let's look at the case 4. We'll come back to how to find the direction here when we are doing an actual question. Let's look at case 5 for that. Case 5. All right, so now let's look at case 5. So case 5, see, the reason why let me tell you the way I teach. I teach in a way that before I start solving questions, I will first of all explain the details to you. So that when I'm solving questions, you don't start telling me, sir, what's happening. So I always take my time to explain every key things to you before I start solving questions. So if you are a student that you just want to solve past question, you are going to be a student that will eventually get hooked in a question because of failure to understand concept. Now let's look at case 5. Case 5 is if two vectors or forces are at obtuse, obtuse angle. Yes, they are at obtuse angle to each other. Now, what do I mean by obtuse? Please pay attention. Obtuse is an angle that is less than 180 degrees but greater than 90. This thing is less so, but this is a combined form of writing integrals. If you separate this thing means theta is less than 180 and theta is greater than 90. So in case you are getting it confused, okay, that's what it means. It's a combined integral. So I mean, it's a combined equality, a combined equality, not integer. So now let's continue. Obtuse angle. F1, F2. This is obtuse. This is acute. So listen to me. Obtuse. Obtuse. Good. Obtuse. Show you your muscle. Acute. Abi? Acute. Obtuse like this. Acute. Obtuse. Don't forget that. So let's continue. Now, this is at an angle theta. So, how can you find the resultant there? The resultant is drawn from common points. That's what parallelogram law is telling us. So, the common point of this guy is this. Are you following? So this is my resultant, FR. Now, let's make this thing parallel so it can form a triangle. So this is like this, then this is also like this too. F1. So this is like this. Okay? So this is my F1. I mean F2 rather. And this is my what? F1. So F1. Now, this is a triangle. I hope you are seeing the triangle. So, where do you think that this thing will be? Where do you think this 180 minus theta will be? To be here. That's it. So, we are still going to apply the same formula. It's not changing. So, my FR squared, hope I put squared here, good. Because what? F1 squared plus F2 squared plus, minus 2F1 minus 2F1 F2. You have to put that formula in your head, oh, please. Put that formula in your head. Minus 2F1 F2 cos 180 minus theta. Yeah. Cos 180 minus theta. So my theta, that's the direction, is still alpha 1, alpha 2. So my alpha 1 is the direction to the F1 force, and my alpha 2, my alpha 1 is direction to the F1 force, yes, correct. And my alpha 2 is direction to the what? F2 force. That's it. So depends on how the question tells you to find direction. But actually, this thing I'm teaching you is mainly for JAMB rarely asks questions on. No, I don't say you should not learn it too, because they can shock you. In fact, there's a JAMB question like that, but it is not really because of the timing in JAMB and also the use of calculators. So they will not really be asking for direction, but it's good you know it as a WAEC student. Okay. Now, before we move to case 5, case 5 is when there are more than two forces acting at a point. But before we move to case 5, let's look at a few questions. So past questions. Let's look at a few questions, guys, before we move to case 5. Now, past question. You see question 1 on your screen now. Question 1 says, an object is acted upon by two forces, 5 Newton and 12 Newton. Calculate the resultant force, the resultant of the two vectors, or the two forces rather, when they are parallel to each other. So this is my question 1. So they are parallel to each other. What did I tell you to do, class? I told you that if they are parallel to each other, you do what? You add them up. So it's telling you that this question was telling you that there's a 5 Newton force moving like this, and there's another 12 Newton force moving like this. So what's the resultant? FR because what? 5 plus 12. That's what? 17 Newton. Right? Good. So that's it. Question 2. So question 2. So in case this, imagine these two things now were opposites. It's going to be 12 minus 7. 12 minus 5, that's 7. So question 2 says, if the same thing, they are perpendicular. So it's saying that if I'm having a 5 Newton force and a 12 Newton force, if they are perpendicular, what is my resultant? So what I tell you resultant is going to be, it's going to be drawn from here. And this forms a what? A right angle triangle. Right? So this is a right angle triangle, this place is also a right angle triangle. So this forms a triangle. So this is my resultant. Now, if here is 5, here is also 5. So Pythagoras theorem, because here is 12, right? So FR squared equal to 5 squared plus 12 squared. Do you understand? So FR squared because so 5 squared plus 12 squared. 5 squared is 25. 12 squared is 144. Add them up, you have 169. That's what? Taking the square roots, FR is what? 13. Yeah. 13 Newton. Correct. So all this is very clear. Alright, so that's question 3. Question 2. Now let's look at question 3. So the question 3 is saying that these two forces, what if they are at 40 degrees to each other? Now we'll solve the question now. Please pay attention. So we'll use this one. Since it's 40 degrees, we'll use this one. I will clean this place. No. Okay, don't worry, I'll just clean everything. I'll clean this place so that you guys can see what I'm doing here. So if it's at 40 degrees, so in this one now, in that question 3, we'll find both the direction. So I'll teach you how to find direction. So if they are at 40 degrees to each other, please pay attention. Let me rub off the board. Okay, so question 3 was just saying, if the 5 Newton and 12 Newton, they are at acute angle to each other, that's 40 degrees, alright? So let's solve. Alright, so 40 degrees. Please, I'll not waste time in this one because I've explained already. So we have so many things to do today. So this is 5 Newton, 12 Newton. They are at 40 degrees. So what do you do first? This thing. First of all, make it form a parallelogram. Alright, make it form a parallelogram. So just make it form a parallelogram by just making it parallel here. I'm making this parallel here. So this is coming like this. These arrows I'm putting in those direction, okay? It's good you put it as a physics student. So this is 5 Newton. So here is also 5 Newton. And here is what? 12 Newton. Alright? So what's going to be the resultant? Drawn from a common point. Abi? So you draw this thing from here. So this is my FR. So if here is 40, here is 180 minus 40. 180 minus 40 is what? 140. That's all. So now, what's the formula I gave you? I said FR squared is equal to F1 squared. Hope I put squared plus F2 squared minus 2F1 F2 cos 180 cos theta. So the theta in this case is 140. You know, I told you that cos. Now let me tell you something. 180 minus theta. This theta is this thing here. So either you just put cos 140 directly, or you say cos 180 minus 40. Do you understand? Don't go and say cos 180 minus 140. No. No. So this is cos 140. Either I say cos 140 or cos 180 minus theta. This will not be your theta. Do you understand? Good. So what's my FR? We don't know. That's my resultant. Is equal to, now please follow me. Let's solve. So what's my F1? 5 squared. My F2 12 squared. So minus 2 into bracket 5 times 12. I mean now, good. Cos 140. So this is obviously a JAMB question because there's no how you can get cos 140 in JAMB. But it's good you know it. Hey, follow me. FR squared is what? 25. This was 144. Minus what? 60 times 2, 120. Cos 140. So let's compute 120 cos 140. 120. Okay, since it's a this, I will just use this my scientific calculator on my phone. This one here. So cos 120 cos 140. This is giving you minus. So this is minus. Listen, this is minus. This alone is giving you minus 91.925. Okay. So this is giving you 169. And this is what? FR squared. Do you understand? So my FR squared will be equal to, so this is plus. So 169 plus 91.65. So this. That's 260.925. So finally, my resultant will be equal to the square root of this one. 16.153 Newton. Good. This is my resultant. Now, I'm making a mistake. Pam, 5 squared, 144. 169, 60 times 2, 120 multiply. So even if I make mistake, it just be the mathematics. But I don't think this mistake is correct. So this is my FR. Now, if the question asks to find the direction of this particular question, so this is my resultant first. So I told you that the direction is this thing. So this direction here. Or so this alpha 1 is to the 12 Newton, and this alpha 2 is to the what? 5 Newton. So how can we get alpha 1? First of all, let's draw this diagram again. Let's draw it out. I'm going somewhere. So this is 140. And this is the alpha 1. Are you getting it? And this place is what? This place is what? 12. I mean now, this place is my resultant. And this place is what? 5. Okay? Now please pay attention. I'm going somewhere. Now, there's what we call sine rule. I made a video already on Lami's theorem. Go and check it out on the screen. It's on the screen now. Go and check it out after this video. I explained what sine rule is. So go and check it out. Now, from sine rule, I can say that my FR divided by, divided by sine 140 degrees is equal to 5 divided by sine alpha 1. This is sine rule. So how does sine rule work? If you have a I'm too kind. But let me just do it. If you have a triangle, but please go check that video. Go check that video. It's very, very important. Okay. So if you have a triangle and you have theta 1 and you have f1 and you have theta 2 and you have f2 here and you have theta 3 and you have f3. So from sine rule, it tells us that f1 divided by the sine of angle opposite f1, that's sine theta 1, and this is equal to f2 divided by the sine of angle opposite f2. So this is opposite this guy, that's sine theta 2, and you have what, f3 divided by the sine of angle opposite it, sine theta 3. So that's sine rule. So that's basically what we just applied here. Okay, good. Now let's now solve. We have gotten my resultant force as 16.153 divided by sine 140 degrees is equal to 5 over sine alpha 1. So cross multiply. You're going to have that sine alpha 1 finally is equal to 5 sine 140 degrees divided by 16.153. And sine alpha 1 finally is equal to, so let's compute this whole thing. So sine, I'm using this calculator because this is a WAEC question. You can use, you have these things on your calculator, on your WAEC. So sine 140 times 5 divided by 16.153. So it means that this is what, 0.19896 blah blah blah. So to find my alpha 1, I basically say sine inverse of this whole thing. So when I take the sine inverse of that, so to find sine inverse, just put shift sine. So shift sine answer gives me 11.48 degrees. So it means my alpha 1, is 11.48 degrees. So it means here is 11.48. Now, what will be alpha 2? This 2. What will be alpha 2? Alpha 2 is going to be 40 minus this thing. Yes, because this whole thing is 40. So this small place is this place is going to be 40 minus this. So my alpha 2 will now be 40 minus this thing. And you press your answer and you get your answer. Okay? So I just went further so that in case your questions ask you. So the resultant of this particular question now is 16.153 Newton at a direction or in a direction of 11.4 degrees to the 12 Newton force, or 16.153 Newton in the direction of, so let's press 40 minus this guy, 40 minus 11.48, 28.52. So in the direction 28.52 to the what, 5 Newton force. That's it. Very quickly, question 4. Now we'll now look at obtuse. Okay, question 4. Question 4 is basically when the 5 Newton force and the 12 Newton are at obtuse angle of 125 degrees. So this is how it should look like. So this is my 5. Let's say this is 5 Newton and this is my 12 Newton. Anyone. Okay, anyone. So if it is at 125 degrees, all right, 125 degrees. Now, how can you define the resultant? How can we find the resultant? Please pay attention. So this is going to be trying to make it parallel. So this is something like this, and this comes like this, Abi. So this comes like this. So this is what, 12 Newton, and this is what, 5 Newton. Abi now. So the resultant is drawn from the common point. So my resultant FR, and this place is 180 minus 125. So 180 minus 125, press. 180 minus 125, that's 55 degrees, abi? So this place is 55 degrees. Now, we have gotten this place at 55 degrees. What's our FR? Simple. We're not looking for direction here. We're not looking for direction. So FR squared is equal to F1 squared plus F2 squared. See, when you write formulas many times, it will stick. Minus 2F1 F2 cos, let's just push this straight, cos 55. Abi, because this is a triangle. So this theta, like this thing you are going to put here, that cos something. That something should be what is directly opposite FR. Okay, so my FR squared will be equal to, this thing is 5 squared plus this 1 squared. So this gave us 169. Check. Minus 2, 5 times 12 cos 55 degrees. That's it. So FR squared is equal to, let's press this thing fast. Just press it once. So 5 times 12 is 60. 60 times cos 55 is 34.414. So multiply by this 2 here. Yeah, I multiply that character, I remember. Times 2. So 169 minus answer. So everything, this thing is giving me 100.17. Yeah, 100.17. But don't forget, don't conclude yet, because you have to take the square. So FR finally is going to be square root of this guy. And this gives me what? FR to be 10.08 Newton. So I intentionally added this question so that you guys can know how to solve resultant force using all the cases. Okay, good. So I hope this is clear. Now, before we move to case 5, before we move to question 5, let's look at case 5. Alright, case 6, which is the most important case amongst all of them, because it's the case that, it's not the most important anyways, everything is important. So it is the case that students find very difficult, and I'm going to break it down for you in details. And this case is known as, when you want to resolve vectors, 2 or more vectors, more than 2 vectors rather, more than 2 vectors acting at a point. Okay, so resolving 2 vectors acting at a point, let's destroy this thing. Now please pay attention. I'm going to use the question 5 of this case to explain, because this question 4, I'll use the question 5 to explain. So before then, look at something. Let me teach you what we call a Cartesian plane. Now, a Cartesian plane, it has the y-axis and the x-axis. Okay, the y-axis and the what? X-axis. Now, there is also something you need to know. You need to understand that this is the positive x-axis and this is the what? Negative x-axis. Negative x-axis. Okay, and this is the positive y-axis and this is the negative y-axis. Now, when resolving any force, when there are more than 2 forces acting at a point and you want to resolve it, any force that is, so we'll always be resolving with summation fx and summation fy. I'll tell you what it means. Summation fx is the total horizontal component and summation fy is the total vertical component. So anytime you want to resolve any force at all right, that is towards this side and you are resolving on summation fx, if it's towards this side, just know that that force will be what? Positive. If it's towards the side, it will be what? Negative. Now, if you are resolving summation Fy, any force up will be what? Positive. Any force down will be what? Negative. Lastly, when resolving for summation Fx, you are going to be using cos. That's not even lastly. Two more. When resolving for summation Fy, you are going to be using sine. Again, when you want to resolve forces, and that force, if it is directly on the x-axis, just know that the angle there is 0 degrees. And if it is directly on the y-axis, just know that the angle there is what? 90 degrees. Now, the last but not the least question. The last but not the least point you need to know is this. You must take all sine and cosine angles to the horizontal. To what? The horizontal. What do I mean? If you have a force here, F1, and you have a force here, F2, and you have to resolve this force, all the sine and cosine you are doing, this theta, it must be inclined to the horizontal. If they tell you that 5 Newton, 2 Newton, and here was 30 degrees, and here is 60 degrees, I want to resolve this force, it's fine to use 60 degrees, but when you are trying to do 2 Newton, you must take this to 60 degrees here. That means it must be to the horizontal. You cannot resolve a force using this vertical angle. The angles must always be to the horizontal. If you now decide to use vertical angle, then these two things will swap. Summation Fx becomes sine, summation Fy becomes cos. It is not good to stress your brain. I know many of you are like, what did this guy just say? It's true. So I'm not saying that it's not possible to use it, but it is more advisable to make sure all your angles are inclined to the what? Horizontal component, both positive and negative. I hope this makes sense. Now, everything I've said, let us put it to application. Question 5. It will appear on your screen now. The diagram is on the screen. Please look at the screen. It says that the figure above shows 4 forces, 3 Newton, 10 Newton, 3 root 3 Newton, and 6 Newton acting on a particle P. The resultant of the 4 forces is, so this is JAMB 2007. Now, the resultant of the 4 forces. First of all, let's quickly draw the forces. I want to draw the forces here so that I can explain something here. Please just pay attention. I intentionally leave I let all these things so that we can always be reflecting. So this is 6 Newton, and it's at angle 60. This is 10 Newton at angle 30, and this is root 3 Newton, 3 root 3 Newton rather. Now, and this is what? 3 Newton. Okay, and this is, all of them are acting at the particle what? P. Okay, so now let's resolve this force. So I told you that when you want to resolve a force, Please put this in your mind. I know many of you have written special angles like 1 billion times in all my videos. Please know it as a physics student. Please. Sine 30 degrees is 1 over 2. Sine 60 degrees is root 3 over 2. Cos 30 degrees is root 3 over 2. And sine 60 degrees, cos 60 is 1 over 2. So we'll use this. Let's start. Now let's start. Okay, and also know that sine 0 degrees is 0. Right? Cos 0 degrees is 1. Sine 90 degrees is 1. And cos 90 degrees is 0. Okay, so let's continue. Now, please pay attention. We want to resolve this force. First things first, always start with either summation fx or summation fy. So let's start summation fx. So the resultant in this particular question, so the resultant of two forces acting at a point, the resultant of more than two forces rather acting at a point is, let me tell you what the resultant is. Please pay attention. So this is how it is. This is the total summation, the total vertical horizontal component, that's summation fx, and this is the total what vertical component, summation fy. So this is the resultant r. So my resultant is equal to, this thing is looking like the case 3. I mean now perpendicular. R squared equal to summation fx squared plus summation fy squared. Do you understand? So this is my resultant and this is my angle. So my direction theta is tan inverse of what? Summation fx opposite of adjacent, summation fy. Summation fy rather, or summation fx. This is the two formulas we need to find the resultant. But first of all, we have to find summation fx and summation fy. Please write this down in your book, okay? I'm rubbing off the board now. Okay, so let's continue. Now, let me show you this recording now. Alright, now, summation fx. How can we do summation fx? Please pay attention. Please pay attention. This is not the time that you be listening to music. Just pay attention. Summation fx is equal to, we are going to touch all the forces. Now, for your speed's sake, note that when you are resolving forces in the horizontal component, so this is horizontal component, fx is horizontal component, fy is vertical. So when you are resolving forces in the horizontal component, any force that is directly aligned on the y-axis should be neglected. I go again. When resolving force in the horizontal component, any force directly aligned on the y-axis should be neglected. Directly aligned mean we say the force dey directly on the what? Y-axis. So this is on the y-axis. What else? Nothing again. So this is directly aligned on the y-axis. So it means that when we want to resolve summation fx, we are going to neglect this 3 root 3 Newton. Why? Because on the y-axis, it is 90. And when we are resolving fx, I told you to use cos. And cos 90 is what? 0. So if you like, you resolve, you will still get 0. That is why it should be neglected for speed purposes. So this guy is out of the way for summation fx. Now, let's start with this guy. 10 Newton. Cos what? 30. And maybe this thing was 60 here. We will not use 60. We have to bring it, we have to make it to the horizontal. That's why I was telling you that everything must be to the horizontal. This is a very important point. So don't get confused. So this is 10 cos 30. Now, is it plus cos 30 or minus, is it plus 10 or minus 10? It is plus 10 because this is, we are resolving x axis and this is the positive x direction. So, and this 10 is in the side. So it's in this side, is the positive side in the Cartesian plane. So this is actually plus. Do you understand? So I'm done with this guy. Now, what of this one? Is this plus 3 or minus 3? Plus 3 because it's still here. So plus 3 cos what? So it is directly on the y-axis, x-axis. It is directly on the x-axis. What's the angle here? 0. If it's directly on y-axis, the angle here is what? 90. So this is cos 0. Now, we are done with this guy. What other force again? Just main this one. Abi? So this 6 now, is 6, is it plus 6 or minus 6 class? It is minus 6. Why? Because it is here. Minus 6 cos what? Cos what? 60. Because it's to the what? Horizontal. I hope this is clear though. You're done. So what's my summation fx? Now let's solve. Summation fx to be equal to. So what's cos 30? Cos 30 is what? Cos 30 is root 3 over 2. Abi? So this is 10 root 3 over 2 plus 3 cos 0. Cos 0 is what? 1. So this is plus 3. Minus cos 60 is 1 over 2. So this minus was 6, 1 over 2. So what is my summation fx finally? 2 here 1, 2 here 10, 5. That's 5 root 3. Plus 3 minus 2 here 1, 2 here 3. So 3 minus 3 cancels out. So it means my summation fx finally is equal to what? 5 root 3 Newton. We are not done. We just resolve the x component. Now let's resolve the y component, summation fy. So when you are resolving, like I said for this one, the way you want to resolve horizontal components, any force directly on the x-axis should be neglected. When you want to resolve horizontal components, any force directly on the y-axis should be neglected. So now we are resolving horizontal vertical component summation fy. Any force that is on the x component or x-axis, sorry, not x component, x-axis should be neglected. It means that this 3 will be neglected. So let's start with this one, 3 root 3. So 3 root 3 is directly on the y-axis. So the angle is 90. So sine 90. Is 3 root 3 plus or minus? 3 root 3 is plus because it is positive. So what else? 10. Is 10 plus or minus? 10 is in this side. Whereas this side, see, no. When you are dealing with x, you bring your hand like, is it here or here? When you are dealing with y, you bring your hand like, is it here or down? Is it up or down? So 10 is up. So plus. Sine, what's the angle? 30. So it must be to the horizontal. 30. Minus, sorry. Now wasabi they do me no vex. So this 3 now is out, abi, because it's directly what? X. So this is the 6. Class, is 6 plus or minus? Minus is coming down. 6 is down. So minus 6. Sine what? 60. So summation fy finally will now be equal to. So this is sine 90. Sine 90 is 1. Check it there. I mean now, good. So this is 3 root 3 plus. So this is 10 sine 30. Sine 30 is 1 over 2. Minus sine 60 is root 3 over 2. I mean now. So this gives me summation fy is equal to 3 root 3 plus 5 minus 3 root 3. I mean now. So 3 root 3 cancels 3 root 3. I'm left with summation fy equal to what? 5 Newton. Now, we have got the summation fx to be 5 root 3 Newton and summation fy to be 5 Newton. Let's find our resultant. So let's find our resultant. So my resultant in this question, so this is my summation fx, and fx is 5 root 3. I need my summation fy, 5 Newton, so 5 root 3 Newton. So what's my resultant going to be? Fr. We have done this already now. 5 Newton, 5 root 3. So this is my theta, don't forget my angle. So my resultant Fr squared is equal to going to be, so you know it's summation fx squared plus fy squared. So that's 5 squared plus 5 root 3 squared, Abi. So this is going to give me what? Fr. This 25 plus 5 root 3 squared means 5 root 3 times 5 root 3. So it means 5 times 5, 25. Root 3 times root 3 is 3. So this is what? 75. Abi? 75, yeah. So add this up. Fr will be equal to what? 100. Abi now? It's not 100, it's 100 now. Abi? So what's my Fr? 10 Newton. Hi! That's my resultant force. So when we want to now find direction, tan inverse of what? I told you tan inverse of summation fy over summation fx. So my direction is now going to be, theta equal to tan inverse. So you know I got summation fy over fx. Not something you should cram. Something you can know. This is opposite and this is adjacent. So twa. I mean now opposite of adjacent. Opposite is the y-axis. Adjacent is the x-axis. So 5 over 5 root 3. I mean now cancel. So I'm having theta equal to what? Tan inverse of 1 over root 3. Now if you recall, for tan 90 is same thing as saying sine 90 over cos 90, because tan theta is sine over cos. So tan 90 is actually undefined. When you get to university, you know what it means properly. So undefined, let's just put it like that, undefined. But tan 0 is same thing as saying sine 0 over cos 0. Sine 0 is what? 0. Cos 0 is 1. So this is 0. 0 over 1 is 0. But 1 over 0 is not 0. 1 over 0 is the undefined for your level. So tan 0 is 0. Then tan 30 is 1 over root 3. Or root 3 over 3. So or root 3 over 3. Then tan 60 degrees is root 3. So if you are saying tan inverse of 1 over 3, 1 over root 3, what is this giving you? Tan 30. So theta is 30. So it means that this whole thing that we just finished solving, the resultant is equal to 10 Newton in the direction 30 degrees to the 5 root 3 Newton force. Yeah. Or 60 degrees to the what? 5 Newton force. Yeah, that's it. Hey. Okay, we have actually done the BB, guys. Now let's start going through main JAMB past question where there will be options. Okay, so I hope this is clear. Very simple. Just find summation fx, find summation fy, put it here, you solve normally. Okay, now let's look at question 6.
My name is Lamide Precious and I scored 335. One thing that I love about Ajaks is the way he's so hardworking and always pushing us to do more in our tutorials, in his tutorials, and also to learn more, to gain skills, to read in the night, to work hard, to do mocks and the rest. Ajaks is really wonderful and I can't thank him enough. And to all the teachers out there who taught in Ajaks tutorial, I also love them. And also the way Ajaks has always pushed us to do more and be better, I really love it. My advice to 2026 JAMBITES that they should come to Ajaks early, because I did not come early. I started very late, around the time of May, April time. that was really late. But what the valuable skills that I learned from Ajaks, all the way it was even easy access. Yes, there was also an easy access, so you can see the topics one by one. That was really helpful to me. And so if you start Ajaks early, I believe that you're going to get even greater scores than I did, and even much more scores. And I hope that Ajaks will progress more in the future, and God will grant him progress.
Alright, so now let's look at question 6. I welcome you back to that tutorial. So question 6 says, a girl walks 40 meters east. So 40 meters east, alright, then 30 meters north. So 40 meters east, alright, 40 meters east, then what? 30 meters north. So north is up. So let's bring this guy down. So 40 meters east, then 30 meters north. Alright, so what the question said, what is the magnitude of our displacement from the starting point? So these are displacement. So the magnitude of our displacement from the starting point is from here to here. Do you understand? So displacement from starting point is basically from here to here. I hope this makes sense. So don't forget that if they ask you to find the distance the girl moved is 70. 40 plus 30. Distance is a scalar quantity. Displacement is a vector quantity. In fact, this thing can also be something like this. You get the resultant. So the same thing we are doing. Okay. So what is this going to be? The displacement d. That's what d squared equals to what? 30 squared plus 40 squared. So d squared will equal to what? 30 squared is what? Press 30 squared is 900. This is what? 1600. This squared will be what? Add them up, you get what? 2500. Simple now. So d will be what? Take the square root, 50 meters. So 50 meters is the answer. Option A is correct. Alright, how that makes sense. Now question 7. Question 7 says, you see it on the screen now, a body, okay, a body of weight. Please, if you have not watched my video on friction, go and check it now, because I explained this thing in depth there. So a body of weight W rests on a smooth plane inclined at theta. So a smooth plane inclined at theta. Alright, so a body of weight W rests on it. Alright, what is the resolved part of the weight along the plane? So along the plane is here. Perpendicular to the plane is here. Don't forget that. Perpendicular to the plane is here. Along the plane is here. So in the actual exam, along the inclined plane, the resolved part is W sine theta. Where is W is mg. So mg sine theta or W sine theta is correct. Anyone is fine. Then if they now tell you perpendicular to the plane, perpendicular to the plane, it's going to be what? W cos theta. That's mg cos theta. So anyone is fine. Along the plane is W sine theta. Alright, along the plane is this. So this is mg sine theta. Then perpendicular to the plane is mg cos theta. That's why your arrow is mg cos theta, because it's equal to the weight. Okay, so good. I hope that makes a lot of sense. Now, what else? Question 8. So for this option B is correct. Good. Option B is correct. Now question 8. You see it on your screen now. A man moves 4 kilometers south. 4 kilometers south. South is down. Then 5 kilometers west. 5 kilometers west. Alright? And then 4 kilometers north. 4 kilometers north. What is his displacement? So, I think the question asks to find the distance. The distance is just 4 plus 5 plus 4. but it asks you to find the displacement. Displacement is a vector quantity and you treat it as a vector. Class, this 4 kilometers is coming like this, and this 4 kilometers is going like this. Class, in the case 2, I told you that when you are having two vectors that is parallel to each other, that is moving opposite side, what do? You what? Subtract. So the resultant vector of this thing is what? 4 minus 4. So that's what? 0. Now, when you have now cleaned out these two things, what are you going to be left with, class? 5 kilometers. That's it. 5 kilometers is correct. So 5 kilometers what? West. Option A is correct. Good. Option A is correct. So I hope that's clear. Very, very, very simple question, and you need to understand how it works. Okay? Now let's move to the next one. Question 9. Question 9 will appear on screen now. Question 9 says, a boy travels 12 kilometers east. So 12 kilometers east, it goes like this. 12 kilometers. Alright? 12 kilometers east and 5 kilometers south. So it goes 12 kilometers east and 5 kilometers south down. 5 kilometers south. Okay? What is the magnitude of its displacement? What is the magnitude of displacement and total distance? Sorry, what is the difference? So the difference between the magnitude of displacement minus the distance, or distance minus displacement, anyone. So the difference between displacement and distance depends on which one is bigger. Okay? Now, first of all, what is the distance? The distance is equal to what? 12 plus 5. That's what? 17 kilometers. But what's the displacement? The displacement is, so this is my displacement. And what do? D squared is equal to 12 squared plus what? 5 squared. This is what? This is 144. This is what? 25. Now, this squared will be equal to what? This is 169. This is what? 13. So the displacement is 13. So the difference be basically what? 17 minus 13. That's what? 4 kilometers. Very simple. Option C is correct. Chilled. Question 10. You see it on screen now. Two vectors, 8 Newton and 6 Newton, act at right angle to each other. What is the resultant vector? So 8 Newton and 6 Newton. So this is my 6 Newton and this is my 8 Newton. So they are acting at right angle to each other. What goes to my resultant vector? So resultant vector is drawn from the common point, the resultant, or F or anyone. So this is the same case, right? 8 Newton. So the same case. Now, just go. R squared equal to what? 8 squared plus 6 squared. So R squared is equal to this 64 plus what? 36. Right? R squared equal to what? Add them up. You get what? 100. R equal to what? Square root of 100 as what? 10. Very simple. Option B is correct. Question 11. Okay, so question 11 is a bit we need space. We need space. So let's rub off the board. An aircraft. So please, if you haven't watched my video on bearing and distances, please go and watch it. Okay? Because I dismantled. I told you guys that those of you that are on my group, I told you that on my WhatsApp group, I said this video, watch bearing and distance before scalars and vectors. I told you before I even release scalars and vectors. So please go and watch it on the screen. Now, an aircraft travels from Calabar to Kano as follows. It flew first. An aircraft traveled from Calabar. So it flew first to Ilorin. Covering a distance of 300 kilometers, 30 degrees west of north. So 30 degrees west of north means north, 30 degrees west. So this is the aircraft. This is my north. This is my west. So it flew 30 degrees west of north. So this is the aircraft. All right. So it traveled from Calabar to Kano. All right, from Calabar to Kano. Now, this point now that I flew from here to here, this place is the Calabar. Right? So, north 30 degrees west. If you watch my bearing assistance video, you understand what I just did there. Now, and then flew 400 kilometers. So this is 300 kilometers, right? So it then flew 400 kilometers, 60 degrees east of north. So this aircraft now, it travels 60 degrees east of north. What is 60 degrees east of north? How do I put this in English now? From here, it went 60 degrees east of north. So from Calabar, it now went to Kano. So this is my Kano. At 60 degrees, this is the east, and this is the north. That's what it means. So it went to Kano. Now, 400 kilometers. This is 300. So the questioner said, so it moved from, the aircraft moved from Calabar to Kano. So it first go north 30 degrees east and west of north. Then when it got to Calabar, it now went to Kano. North 60 degrees east of west. East of north. Okay? So what's the resultant displacement? So the resultant displacement is basically the distance from the starting point to the ending point. The resultant displacement. That's it. So how can you do this now? Please pay attention. I want to change my marker so you guys can see the angles clearly. This is 30 degrees. Right? This is 30 degrees. If here is 30, we're looking for this resultant displacement, Abi. Since we know this place, If we can get the angle here, we can now understand whether this angle is a right angle triangle or is just a normal triangle. So this place is 30. This place is alternate to this place. So it means that if here to here is 30, then here to here is 60. And this place, which is 60, if here to here is 60, it means here to here is what 30. Plus, 30 plus 60 makes this thing 90. Therefore, this angle is a right angle triangle. Do you understand? So this angle now, if I want to draw it properly, it's going to be like this. So this is my Calabar. This is the aircraft. This is 300. And this is my Kano. This is 400. Do you understand? So the resultant displacement is this. From the Kano to the aircraft. Abi? That's it. So this is 90. That's the angle between this thing. 90. That's it here. So this is a full right angle triangle. What do? RD squared equal to what? 300 squared plus what? 400 squared. RD squared is equal to, just press this together, let's not waste time. 300 squared plus 400 squared is what, class? 300 squared plus 400 squared is 250,000. Take the square root, guys. Take the square roots. 500. Good. Kilometers. Option D is correct. Yeah, option D is correct. So how this makes sense? Please, if you don't understand this thing, just go and watch my videos on bearing and distances. Okay? Now let's move. Question. Where are we now? This is question 11. So question 12 will appear on your screen now. And question 12 says, the resultant of two forces acting on an object is maximum if the angle between them is. So, the resultant of two forces acting on an object, if the angle between them, the answer is actually 0 degrees. I will explain. I'll explain. You know, we have this formula here. This question 12. The formula is F1. The formula is R squared. That's resultant squared equal to F1 squared plus F2 squared plus F3 plus minus 2 F1 F2 cos theta. Now, if this theta is 0, cos 0 is 1. So it means that I will get a maximum value of my resultant if this whole thing can be 1. Because if theta is not, if this whole thing is not 1, it's definitely going to be less than 1. Which will reduce my resultant. So if this theta can be 1, then if this cos theta can be 1, then my resultant will be maximum. That will be the maximum value of the resultant. I hope that makes a lot of sense. Okay, so the answer is what? 0. Don't forget, theta is 0. It gives the maximum resultant. If theta is 180, it gives a what? Minimum resultant. Why? Because cos 0 is 1, but cos 180 is minus 1. So don't forget that. Okay? Good. So 180 gives a minimum resultant, maximum resultant is 0. Question 13. Question 13 will appear on screen now. And it says, an aircraft flies due north. The aircraft flies due north. This is the north. Alright? For 100 kilometers per hour. A wind now blows from east to west. So the wind is coming like this. From east to west. East. West. Okay? And the wind is coming with a velocity of 60 kilometers per hour. What is the resultant velocity? Very simple. So the resultant is always drawn from the common point. The resultant. Please don't go and make this mistake. Let me tell you, don't go and make this mistake. Say not. Okay? Then from here, you now come like this. No! They don't tell you that. They don't tell you anything like that. It's not like this question that they say it's moved from Calabar to Kano. No. The aircraft is going. But the wind is coming to its own velocity. It's not the same. So you can't measure them like that. So this is my resultant. So first, let's find the resultant velocity. So if you look at the questions, the option is telling you to find resultant velocity for magnitude and its direction. So let's first find the magnitude, right? So how can we do this magnitude? Just go r squared is equal to 100 squared plus 60 squared. Let's do this very fast. Just do this very fast. Press the calculator. 100 squared is 1000. So let's go 100 squared plus 60 squared. Take the square roots. You're going to get 117. So 117 kilometers per hour is my magnitude. Alright, from the option, there are two 117 there. So you need to know which one. You need to know whether is it option, where's the question now? Is this option B or option C? Now, we have gotten the magnitude. How can we get the direction? Option B is saying north 31 degree west, while option C is saying north 31 degree east. How can we know? This is north, this is west, this is the direction of the resultant. Class, it is in the northwest direction. So without even solving, you should know that option B is correct. But let's solve. It's in the northwest direction. Let's solve and we'll see how they got out 31. So the angle, listen, when you want to, let me not even confuse you. Let's just put so like this theta. Abi now. So what's this theta here? This is from the triangle. So this theta opposite over what? Adjacent. So what's my opposite? 100. Adjacent is 60. So tan theta is what? Opposite 100 over 60. Abi? Good. So 100 over 60. So theta is what? Tan inverse of 100 over 60. So theta is what? Now, Press your calculator. JAMB is wicked. But you know, this is a JAMB question. Oh. But you might be, sir, how can we do tan inverse of this thing? You know, if I was writing JAMB, all right, and I see this question, I'm not even going to solve to get 31 because I clearly know that the angle will be the northeast. See, they have given you a expo from there. This is north and this is east. So the resultant is here, northeast. Do you understand? It is here, northwest. I mean northwest. So this is north, east, west, south. Northeast, northwest, southwest, southeast. Do you get? Good. So my theta will be 100 divided by 60. So tan inverse, that shifts then tan, you get 59. Now 59 degrees. Class, I told you in bearing and distance video that anytime you want to represent an angle in a compass bearing is always not something degree east, not this, the angle must be to the what? North or to the south. So this is theta 2, this is theta 1. So theta 2 is what I'm looking for. And this is a right angle triangle. So theta 2 is what? 90 minus 59. That's what? 31. So this is 31 degrees. And that's why we are having a direction to what? A direction for now is what? North, 31 degrees east. West rather. West. Okay? Very correct. Very correct. Very, very simple. Option B is correct. Alright, so how that makes sense. Now question 14. This is a theoretical question. So which of the following comprises of vectors? So friction and momentum is a vector. Don't forget that. Capacitance, inductance, nah. Force ratio, nope. Force ratio doesn't even have a unit. Can't be a vector. Never. Velocity ratio, no units. Can't be a vector. Never. Energy, no. Power, no. The answer is what? Friction. Frictional force. We have done that already. Abi? So frictional force and momentum, they are both vectors. Okay? So option A is correct. Now let's remove the board so we can move to question 15. So question 15 will appear on your screen now. And question 15 says, if a man walks 40 meters due west, so 40 meters due west, 40 meters due west, and then 30 meters due south. So where is south? Down, Abi. South. So this is west, and this is what? South. So the distance he moved there was 30 meters. So calculate displacement. So the displacement is actually the resultant. Abi, fill my displacement. And on the Cartesian plane, I mean on the cardinal point, this is what? In the what? Southwest direction. Don't forget that. It's in the southwest direction. So any angle you are getting is in the southwest. And this is where the angle will be, theta. Do you understand? Because it's to either the north or the south. I've told you. So this is 40 and this is 30. We can easily get my D now. I mean, my D, my distance, the magnitude. So the magnitude is going to be, that's this squared equal to 40 squared plus 30 squared. Do this on your own. This is 50. Now, this angle, this is the opposite, right? And this will correspond to 40. And this is my adjacent. So it means my tan theta is what? 40 over what? 30. So my theta is what? 40 over 30 is what? That's tan inverse of, what's 40 over 30, class? That's 1.33. So what is my theta finally? Okay, so my theta is tan inverse of 1.33. Wait till I do this one now. Yeah, 53.0. 53.0 or 50 degrees approximately. So now from the option, there is A, 30 meters south 50 degree west, B, 50 meters south 50 degree west, C, 50 meters south 37 degree west, and D, 40 meters south, 53° west. So what's my answer? 50 meters south, because it's in southwest. South what? 53° west. If you go and use this place here, you get 37 and you fail it. So don't forget that anytime you're doing a cardinal bearing, all this theta must be to either the south or to the north. Do you understand? Good. So this is what? Option B is correct. Okay? So let's move to question 16. Question 16 will appear on the screen now. It's very simple. Which of the following quantities is a vector? So a vector quantity is a quantity that has magnitude and direction. A, temperature. Temperature is not a vector. Electric field is not a vector. Electric field is a vector. Power is not a vector. Energy is not a vector. So electric field is a vector. Anything field is a vector. Don't forget that. Magnetico, gravitational field is a vector. Now, question 17. Question 17 says, a boat travels due east 40 meters per second. Alright? Across a river flowing due south. So the river is flowing through south at 30 meters per second. What's the resultant speed of the boat? Do you understand? So the boat is going like this. The river is going south. What's the resultant speed of the boat? So the resultant here, that's it now. R squared equals to what? 40 squared plus 30 squared. We have done this 1 billion times, 50 meters per second. Option A is correct. Okay, very simple. Question 18. Two cars, two cars moving in the same direction at 100 kilometers per hour and 130 kilometers per hour. What is the velocity of the faster car as seen from the slower one? Now, questions like this is what we call relative velocity. I am not wasting your time, trust me. Note, any relative velocity question you see, if it is opposite, you add the velocities. You add velocity. If it is in the same direction, you what? Subtract. Subtract what? Velocity. Okay? So, how can you know a relative velocity question? It's very simple. They'll tell you, either they tell you to find the relative velocity, or they say, what is the velocity with respect to this, as seen from this, from a position of this. So this question, they say a car moving in the same direction. If it is in the same direction, we do what? We subtract. So my relative velocity, RV, is going to be equal to what? 130 rather, minus 100. That's what? 30. Where you done? But you say this one for JAMB, you go just smile. Option C is correct. Question 19. A boat travels due east. Oh, question 19 is same thing with question 17. Oh, sorry. Just try, it's bonus. So the answer is what? 50 meters per second. Okay? 50 meters per second. Now, question 20. Yeah. It is a relative velocity question. You see it on the screen now. It says, a car is moving 50 kilometers per hour east and a train 70 kilometers per hour west. So this one is moving east and this one is moving what? West. What is their relative velocity? Class, I told you. When it is opposite, you what? Add. So the relative velocity for that question is what? 50 plus 70. That's what? 120 kilometers per hour. Keep done. That's the answer. Option A. You see, when you join other tutorials, you are going to understand how to solve JAMB questions fast. No need to waste your time. Let's move to question 21.
My name is JAMB WAEC, and I was able to secure 333. My experience in Ajaks tutorials was wonderful. The tutors I met were experienced tutors who drilled us with past question sessions. The follow-up coach always ensured that we were not lacking in every class. And even I got an opportunity to meet scholars who held brainstorming sessions that kept us on our toes. My advice to 2026 UTM students is to enroll in Ajaks tutorials because it's a place to be. My scores skyrocketed from downstairs UTM from 200 226 to 333. So it takes scholars from 0 to hero. As Ajaks tutorials, no one here is a dollar.
Welcome back. Now let's look at question 21. You see it on your screen now. Question 21 says a lorry travels 10 kilometers north. So 10 kilometers north, all right, 4 kilometers east, 4 kilometers east, 6 kilometers south, 6 kilometers south, okay, what else? And 4 kilometers west, 4 kilometers west. See, the proper representation of this thing is actually 10 north, 4 east, do you understand? 6 south, like this, you understand? So this is actually the proper presentation, but I want to show you guys something that's like, so this is 10, this is 4, this is 6, and this is 4, okay? So now let's look at this. We have to find the total displacement. So total displacement. Now, how can we get total displacement, class? This is 4 here, this is 4 here. The resultant here is already 0, cancelled out, because 4 minus 4 is 0. So this is 10 up, this is 6 down. 10 minus 6 is what? 4 kilometer. Now 4 kilometer way. I told you that when I was teaching you the opposite case, I told you that the direction will be where the magnitude of the bigger force is. So the bigger force is in the north direction. So it means that the resultant is going to be 10 minus c, which is 4 kilometers north. Very simple. Option D is correct. Okay, so option D is correct. Option D. Now let's look at question 22. Okay, so question 22 says a man moves from a point R 2, minus 3 to a point S 7, P. The distance the man moved was 13 kilometers. What is P? Now, let me tell you guys this formula. Please note this formula down. Like now. Write it down. Distance between 2 points. Distance between 2 points. Alright, so distance between 2 points is giving us, listen, this squared is equal to x2 minus x1 squared, or it's all squared, plus y2 minus y1 all squared. So this is finally d equal to, take the square root of this whole thing. Are you following me? X2 minus x1 all squared plus y2 minus y1 all squared. So we have this x comma y. Don't forget that. So when I read x comma y, a point is in x comma y format. So it means anything that comes first is x, anything that comes first second is what? Y. So they said point R is 2 minus 3, all right, and point S is 7 P. Do you understand? Now they only told us that distance is 13. So this thing means my x1 is 2, right, and my y1 is minus 3. I told you x comes first, then y next. So this means my x2 is 7 and my y2 is what? P. Are you following me? Now this is the formula. Let's use this one. We can't use anyone actually, but let's use this one. This one, just use one you want to get d, but they have given us d already. So this is d squared, and this is what? 13 squared equal to, what's your x2? 7. What's your x1? 2. 7 minus 2 squared plus, are you following me? Good. What's your y1? Y2? Your y2 is p minus, what is your, now please pay attention, y2 minus y1. What is your y1? Minus 3. So minus times minus 3. Are you following me? Good. So what's this? This is 169 is equal to 7 minus 2 is 5. Are you following me? Good. So 5 squared plus p plus 3. Don't forget this is in bracket. All squared. All squared. Don't forget that. Now, what's the next step? This is 169 and this is 5 squared. So 169 minus 25, that's when you bring it here, right? Is equal to p plus 3 all squared. Are you getting what I'm trying to say? So this is what? 144 and this is what? P plus 3 all squared. Now you can take the square roots. When you take the square root, this thing cancels out. What are you going to be left with? Square root of 144 is what, class? 12. And this gives me what? P plus 3. Take this p here. So I'm having that p equal to. So bring this 3 here. 12 minus 3. And that's what, class? P will finally be what? 9. Option C is correct. Very simple. Very simple question. Okay? So question 23. Let's solve question 23 together. Next slide. Question 23 will appear on screen now. Question 23 says, if the resultant between two forces is 12. If the resultant between force 12 and force 5 is 13, what's the angle between them? So, if you have a question like this, just use this particular formula. R squared equal to F1 squared plus F2 squared minus 2F1 F2 cos theta. So, this is actually the main cosine rule formula. Okay? So, this, because why is this formula? Because that's the general formula to be able to find resultant. Do you understand? So, it's just because the angle sometimes might be 90. That's why we used to clean all these things. So, let's just assume. They tell us that the resultant is 13. And the first force is 12. And second force is 5. Minus 2 times 12 times 5 is 60. Cos theta. So, we don't know theta. This whole thing now. This is 144. This 25. This will give you 169. And this gives me 169. Minus 2 times 60 cos theta. This gives me 160 minus 160 is 0. Minus 2 times 60 cos theta. So 0 divided by anything is 0. Okay, so when you divide this through by 0, you have that cos theta is equal to what? 0. Alright, so from here now, what do? You say theta is equal to what? Cos inverse of 0. So cos inverse of 0 is what? 90. Because cos 90 is what? 0. Okay? So for my option D is correct. Option D is correct. Correct. Now, question 24. You see your screen now. A body on the ground is acted on by 10 Newton force at an angle of 60 degrees. So a body on the ground is acted upon by a force 60 degrees. And this force is 10 Newton. What is the force that is necessary to make this body stop moving forward, moving eastward? So this is east. So this body is actually meant to move east. So what's the force what's the force that will stop the body from going like this? Frictional force. Do you understand? It's under scalars and vectors actually. I will explain. So this is the force. Now, this is my east. If here is east, it means here is what? West. So this is the force, main force. And when you want to resolve horizontal component, don't forget that horizontal component is equal to what? F cos theta. We have done this already in friction. So this gives me what? 10 cos 60. And cos 60 is 1 over 2. So 10 cos 60 is what? 5 Newton. So this is 5 Newton east. So 5 Newton east is the force that is meant to move forward. But the question says, what is the force that will stop this body from moving? That's what? 5 Newton west. Option B is correct. Do you understand? Good. Question 25. You see it on your screen now. A driver is moving with a uniform speed of 40. Observed a truck approaching from the opposite direction at 20. What is the relative velocity? I've told you. Once it is opposite, what do? You add. So, what's the relative velocity finally? 40 plus 20. That's what 60 meters per second. Correct. Option C is correct. Alright, so question 26. Question 26 says a 5-kilogram body at rest is acted upon by two perpendicular forces. So this is the body. So it's acted upon by two perpendicular forces, 5 Newton and 12 Newton. Alright. What's the magnitude of the acceleration? So this is the body and two forces. So what's the magnitude of the acceleration? Remember that F equals ma. So first, to find acceleration, we need to find the resultant force. We have done 12 and 5 tire to know that the resultant force is already 13. So we have gotten 13 Newton as resultant force. We now say F equals what? Ma. That's 13 is equal to what? What's the mass? They told you mass is 5. E. So what's my acceleration, class? 13 over 5. Press your calculator. Acceleration is finally what, class? 2.6 meters per second squared. Option D is correct. Very simple. Question 27. Question 27 says, this is the same thing. A block of mass 2 kg on a smooth plane is acted upon by 10 Newton and 10 Newton. So a 10 Newton north and 10 Newton east. North. So what is the magnitude of the acceleration? So it's acted upon by a body. So these two, this are acting on this body. So the magnitude of the acceleration, first you find the resultant force. That's Fr or Rn1. So what is Fr? Equal to the square root of these two things. So 10 squared plus 10 squared. 10 squared plus 10 squared. So Fr is equal to, this is 100 plus 100. That's 200. That's square root of 200. And square root of 200 is the same thing as saying root 100 times 2. So Fr will be equal to what? 10 root 2 Newton. So F equal to Ma. So Fr equal to Ma. Finally, what is my Fr, class? 10 root 2 equal to, what's my mass? They told you it's 2. A. So it means my acceleration is what? It means my acceleration is what, class? 5 root 2 meters per second squared. So when you press your calculator, you get it as 7.07. Option D is correct. We're moving very fast. Now, the last question in this video, question 28. The last question. It says, you see your screen now, a ball is moving at 18 meters per second squared at 30 degrees to the horizontal. So the ball is moving at 18 meters per second squared at 30 degrees to the horizontal. So this is my horizontal. The ball is moving, okay, 60 degrees to the horizontal. What's the horizontal component? So the ball is moving with a velocity of what? 18 meters per second. So when you ask to find, listen, anytime you ask to find horizontal component, just do the vector cos theta. Again, the vector cos theta. So what's the vector? 18 cos 60. Cos 60 is 1 over 2. 18 times 1 over 2 is 9. 9 is correct. Sorry, 9 meters per second. That's the answer. As my option what? D is correct. So this is very simple. So anytime you have to find horizontal component is the vector cos theta. Anytime it's vertical, if it's vertical, is the vector sine theta. I hope this makes sense. So yes, we are done with this video and we trashed 28 JAMB and WAEC questions. All right, clap for yourself if you watch the video to the end. It shows you're actually a very serious student and you really want to know scalars and vectors. And yes, I hope by now our knowledge on scalars and vectors should be 100%. Okay, so I'm going to urge you, I'm going to advise you, I implore you, please and please try to practice more questions. All right, if you have any question at all, drop in the comment box I remain Ajaks, your Ajaks Tutorials, and yes, if you enjoyed this video, do well to like, share, and subscribe. And if you are a JAMBITES post-UTME, I don't know when you're watching this video, although I'm dropping this video, I'll drop this video November 3rd, November 30th. If you're watching this video during this period, we're organizing a JAMB class for all 2026 JAMBITES. But if you're watching this video anytime, classes are ongoing. We have classes for WAEC, JAMB, NECO, post-UTME, 100 levels, and JUPE programs. Alright? I remain Ajaks, CEO, founder of Ajaks Tutorials, and I hope you enjoyed this video. Have a lovely day. Bye. 2026 JAMBITES come close. In 2025, Ajaks Tutorials produced 239 students with 300 plus, and we had our top student emerging top 8 in Nigeria, 372 over 400, as Onyeme Samuel. Now, over the years, I've understood that many students that fail JAMB, they don't fail JAMB because they don't read. Alright, many of them, they don't have the right guidance. Ajaks Tutorials 2026 JAMB classes is going to be starting January 5th and runs down till your examination. The fee for this class is 8,000 naira monthly. We have other plans for you. In case your parent or guardian want to pay for more than a month, we have the plan for you. To be a part, click the link below now, text number on your screen. Remember, in 2025, we are 239 700 plus. 2026 will not be any different. Class is for science students only, and class holds online. We use WhatsApp, Telegram, YouTube, and our mock portal for our classes. Click the link below now or text number on your screen to make inquiries and enroll. Have a lovely day. Bye.